Hello, everyone. My name is Veronika Vasilkivska. I'm a research scientist at National Energy Technology Laboratories through LIDA's Research Support Team contract. Today, I will provide a brief update on some of the newer functionality available in NRAP's open source integrated assessment model for geological carbon storage. Before beginning, I would like to acknowledge the contribution of the development team with members from the 5 partnering national laboratories who were um, actively engaged in the source code and example development, writing manuscripts and reports on the tool application, and helped to put together this presentation. That is to say, acknowledgements and disclaimer are necessary but not sufficient parts of the presentation. I also want to acknowledge the lineage of NRAP's integrated assessment model. The first version of IAM was developed by a team of researchers at Los Alamos National Lab in 2009. The model included first-of-a-kind representation of saline aquifer storage and possible CO2 release through migration pathways, such as wells and faults. The model allowed representation of CO2 sources, transport and injection, and related costs. Through the first phase of the NRAP from 2010-2016, researchers focused efforts on improving IAM functionality to better characterize long-term performance of geological CO2 storage sites. Users were able to quantify risk profiles for selected parameter distributions of reservoir, seal, sieve zone, groundwater, aquifer, and well properties. In the second phase, researchers have migrated the IAM from commercial stochastic simulation platform GoldSim to an open source in Python, and we continue to refine and expand the tool capabilities. The open source nature of the NRAP OpenIM ensures flexibility in incorporating different component models, different risk assessment approaches in a single model instance. Users can modify the source code to build case-specific scenarios, and we hope that this capability would facilitate the community contributions to the software as well. At its core, the NRAP OpenIM allows users to define site-specific geological carbon storage scenarios, characterize important site features, events, processes, take into account uncertainty, couple together reduced order models of various system components to rapidly forecast response to CO2 injection, and perform stochastic analysis to quantify containment effectiveness, leakage risk, and impact to receptors of concern. The tool capabilities enable researchers to perform stochastic analysis of containment effectiveness, quantify fluid migration to monitoring intervals and receptors of concern, and estimate impact to receptors. As a result, users have a site-specific quantitative representation of leakage risk as they evolve over time. Building on the core capability, the team is developing new functionalities for fit-for-purpose analysis that may be useful to support design and decision-making at geological carbon storage sites. I will provide just a few examples here. Several of these examples and applications will be discussed in more detail later in the meeting. For the first example, I would like to mention the work on the probabilistic evaluation of plume stability. The team developed several plume migration metrics such as area, rate of change, mobility, spreading, that can be used for any quantity of interest, such as pressure or saturation. The metrics are based on spatial moment analysis methods and can help quantify the spatio-temporal evolution of plumes at geological CO2 storage sites. It is known that the evolution of reservoir plume can be determined by many factors, ranging from geology and stratigraphy to injection extraction regimes. As part of its source code, NRAP OpenIM provides several examples which illustrate probabilistic evaluation of plume stability based on ensembles of simulation and how this type of analysis can support conformance analysis. The conformance concordance assessment is my second example here. I would like to mention the Sleipner project. The project was important to demonstrate and advance 4D seismic monitoring technology and to begin to use the data to assess plume conformance. Motivated by that, the NRAP team has developed approaches to evaluate the acceptability of uncertainty in plume response and to constrain that uncertainty over time. This type of analysis can build confidence and performance at the storage site will conform to expected and accepted behavior. NRAP OpenIM tool provides capabilities which allows to assess robustness of plume conformance to uncertainty and to estimate how monitoring data can help constrain uncertainty. The third example illustrates application of NRAP OpenIM tool for evaluation of risk-based AOR. A little bit motivation here. Sites with initially overpressured storage interval may benefit from quantitative and probabilistic assessment of risk-based area review. The current release of the NRAP OpenIM includes a script example that is essentially a conceptual workflow illustrating how to delineate the risk-based area of potential impact using stochastic representations of reservoir, open wellbore, and groundwater aquifer responses. Estimates of detectable impact can be compared to potential impact areas defined using alternative approaches and help to support decision-making about site characterization and monitoring requirements. If you're interested in some more details regarding this and other application, make sure to not miss a presentation by Diana Bacon on November 5th when she will provide some more details about this development. The last example in this presentation is the work done on the post-injection site care and site closure. For Class 6 wells, site-specific observations and forecast serve as the basis to ensure protection of underground sources of drinking water and justify site closure. Uncertainty in post-injection site care duration corresponds to uncertainty in financial responsibility costs. Before the site can be closed, the operators and regulators need to be confident in non-endangerment of groundwater sources. The NRAP OpenIM has capabilities that can be used to understand potential for USDW endangerment during and post-injection and help to support a justification for reduced post-injection site care period. The team published several manuscripts for which NRAP OpenIM simulation have been used to explore how risk-based justification for site closure might be made at greenfield sites and sites with many wells. Moving forward, we hope to further refine system component reduced order models to improve ability to represent monitoring and detectability and support of risk-based monitoring network design and performance evaluation, to demonstrate the tool's ability to evaluate risk management, performance scenarios, and of course, we want to develop additional useful fit-for-purpose applications. Just a small reminder here, the NRAP OpenIM tool can be accessed from the Intel EDX website or from the public GitLab repository. The data sets that can be used to test some of the tool capabilities can also be found there. If you have any questions or comments on NRAP OpenIM, please feel free to reach out to me directly or contact the NRAP project coordinator using any of the means listed here. Now I will pass to Dr. Mark Brandyberry with Illinois Rockstar, who will talk about his teamwork on the development of commercial quality graphical interface for NRAP OpenIM. And thank you everybody for your attention.
Hello, I'm Mark Brandyberry from Illinois Rockstar in Champaign, Illinois. I am a principal investigator on a DOE Phase 1 SBIR, tasked to work on user interfaces for the OpenIAM software package. Our team, including Lei Jin and Jenny Lee Benda, have been working on the project for the past 4 months, and today I'm going to give you a taste of what we're doing. For those of you who don't know Illinois Rockstar, we are a 25-person small business out of Champaign, Illinois, that does engineering software development. A scattering of visualizations from some of our projects in fluid dynamics, solid mechanics, advanced meshing, nuclear reactor modeling, electrochemistry, and cloud computing are shown here. Over the past 5 years or so, we've been working on interfaces for scientific tools, including cloud computing, which we will touch on in a moment. The goals of this project are twofold. producing a robust graphical user interface for OpenIAM, and generating packaging and distribution mechanisms for both the GUI and the OpenIAM software itself. The GUI needs to support users from subject matter expert scientists to technical regulators. We are interviewing users, reviewing the other tools such as the DOE Advanced Simulation Capability for Environmental Management Architecture system, looking at interfaces for reservoir modeling tools, and more. The packaging mechanisms should be simple and easy to install for non-programmers. Shown here are very early conceptual drawings for an OpenIAM graphical user interface. They are based on some internal thoughts, but for the most part are driven by our user discussions. We are looking at an increase in visual feedback, including a view from above the site showing well locations and a stratigraphy view. Interactively building the stratigraphy visually is anticipated. We are intending to use the Electron open source toolkit that allows building rich desktop applications using web languages such as JavaScript. One reason to use JavaScript and Electron on the desktop is the ease of transfer of the resulting interface to our cloud computing system at Simverse.com. Simverse is an always available application for running science tools in the cloud. Our goal is to have the same OpenIAM interface both on Simverse and on the desktop. Given the no-install browser-based system with a pay-as-you-go model for access to almost unlimited computing, Simverse will support users without compute facilities or that are just looking for convenience. The figure on the right shows the ParaView visualization program running remotely on Amazon Web Services hardware and displaying locally in a browser on your desktop. Thus far, we have directly talked to 3 different organizations about their experiences with OpenIAM. We're looking to learn about their workflows, or what do they really want or need to do when they open the OpenIAM tool. We are also currently working with the Illinois State Geologic Survey to watch as they begin a program using OpenIAM. We are recording interviews when allowed, and we need more people to talk to. If you are willing to spend an hour talking to us about your OpenIAM experiences and things you would like to see, please contact me at the email on the slide. And if you ever doubt the need for talking to your users, consider the cartoon showing how a lot of software is developed. Our philosophy here is shown in the blue box on the left. Basically, most end users don't care about technical implementation. They just want to get stuff done. This is a quote from Gregory Zork, author of the PyOxidizer package that we're looking as one possibility for packaging Python code, describing the Python app distribution problem as an existential threat. Essentially, he means for the future of Python being used for deployable applications. So basically, if you're not a Python developer, it can be hard to get a new Python tool running on your machine. We need to be cross-platform, easy to install by an end user, and able to handle installation of both our new GUI and the OpenIAM tools. For a path forward, we are 4 months into a 9-month Phase 1 project, so have over half our time left. By the end of this Phase 1 SBIR, we want to have designed a draft GUI based on user input, prototyped some of that GUI in the Electron system, and tested 1 or more methods for packaging the Python code. This should give us a good base for moving into a Phase 2 SBIR project. I like the quote in the bottom right. It says, "A user interface is like a joke. If you have to explain it, it's just not that good." That rings true to me. So here's contacts for me and for the 2 developers on the project, as well as our websites. Please feel free to contact us at any time. Thank you very much for your time.